Investigation 2.3, choosing random samples. All right, guys, again, I stress that you are working with your partner, listening through and reading along in the book through the investigation, stopping and answering questions with your partner, making sure these questions are fully answered in your notebook, and then pausing for questions that you might have for myself. All right? So, choosing random samples. In most cases, a good sampling plan is one that gives each sample selected from a population the same chance of being chosen. Sampling plans with this property are called random sampling plans. Samples chosen with random sampling plans are called random samples. To select a random sample from a population of 100 students, you could use spinners like these to generate pairs of random digits. What two-digit number can you generate with these spinners? What are the current location of the spinners? What two-digit number could you generate with that? How could you make sure student 100 has an equally likely chance of being included in your sample? So how could we make sure student 100, because there's only two digits, so if you said 41 or 14 using the 4 and the 1, how could we make sure that student 100 had a good enough chance of getting chosen as student 41 or student 14? There are many other ways to select a random sample of students. For example, you could roll two 10-sided solids or generate random numbers with your calculator, which is actually what we're going to do in this investigation. So I'll show you how to do that later. But why don't you go ahead and pause the video and answer those two questions above with your partner. Okay, getting ready problem. Suppose you have 2 concert tickets. You want to choose one of your 6 best friends to go with you. Consider these possible strategies. Strategy 1, choose the first person who calls you tonight. Strategy 2, assign each friend a different whole number from 1 to 6. The number you roll on a 6-sided number cube determines who goes. Or strategy 3, tell each friend to meet you after school. Toss a coin to choose between the first 2 friends who arrive. You want to give each friend the same chance of being selected. Which strategy would accomplish this? Explain. Describe another strategy that would give each of your friends an equally likely chance of being selected. So why don't you talk to your partner, pause the video, and answer those 2 questions about those 3 strategies. The table on the next page shows data collected on a Monday in an 8th grade class. The data includes the number of hours of sleep each student got the previous night and the number of movies each student watched the previous week. We can use statistics about a random sample of these data to make predictions about the entire population. So if you turn the page, you see this wealth of data here. 100 students were polled about how much sleep they got the night before and how many movies they watched the week before. Okay, so that's the data that we're going to use. What you're going to do is you're going to use your calculators to choose a random sample. And then we're going to represent our samples with line plots. And we're actually not going to use box plots. We're going to use a scatter plot. So before we do that, we should talk about what kind of a scale we're all going to use, because you guys are going to be comparing these. So just to remember, a line plot looks like this. Remember, we looked at these line plots about the regular peanut butter histograms. I'm going to allow you to make either one of these 2. All right, so we're going to use the little dots and kind of place the peanut butters where they go. We're going to be making a line plot of the movies. And so when you guys make a line plot of the movies, our maximum amount of movies, I think, was somewhere between like 17. So we're going to go from 0 to 20, okay? And we're going to use intervals of 10, okay? So as you go about making your line plot, it should be something like this, okay? So similar to this here, but we're going to go from 0 to 20 instead of 0 to 100, and ours will be titled something about number of movies that 8th graders watched. Okay, make sure you have a nice title there. All right, but we actually haven't even gotten to that question yet. So, but when we do that, our scale there will be scale of 2. okay, for the movies. And I think eventually we'll get to a scatter plot of the movies versus the hours of sleep. So again, we'll use the x-axis here as movies from 0 to 20, and then I think the y-axis of sleep, I think the maximum was almost 12, so we'll go to from 0 to 12, and you can probably count by ones there. Okay, this was supposed to be a 20. Good. All right, so question A, you're going to choose a random sample to represent your sample with a box plot or a line plot and a scatter plot. And we've chosen our scale, so let's get to question A1. We're not going to use our spinner, we're going to use our graphing calculator. Okay, so if you can get your calculator or pause the video and get a calculator, I'll show you how you can generate random numbers. Okay, we're going to generate 30 random numbers to represent 30 students. Okay, so and notice here your sample should contain 30 different students. If you select a student who's already in your sample, select another one. Okay, so if your random number generator selects more than one, of the same number, you're gonna have to choose a different number again. All right, so on your calculator, if you click math and then scroll over here 1, 2, 3 times to probability, we're going to choose number 5, random integer. So if you scroll down to number 5, or just hit the number 5, it'll scroll up random integer. We're going to choose a random integer from 1, so type 1 and then comma, which is right above the 7 here, 1 comma to 100, and then close your parentheses there. And if you push enter now, it should just generate a random number from 1 to 100. So you can see I got 95. If I hit enter again, 91, 15, 52, 41, 74, 5, 34. I can keep on going there, and it will give me random numbers. Make sure that if you have a number that appears more than once, you need 30 different numbers. All right? So if you need to, go back and watch that again so that you know how to generate those 30 different students. All right? And write each of those students that you're going to use in your notebook so you know what your sample is going to be. All right? For each student in your sample, record the number of movies they watched and the number of hours they slept. Okay, so in your notebook, you should have 30 different records of which student it was. So you can go to your table here, your student number. So if you chose one of your numbers was 13, how many hours they slept and the movies they watched. Okay. B1, make a line plot showing the distribution of the movie data from your sample. So again, on that line plot, you're going to be from 0 to 20 with intervals of 2. Okay, and then you're just putting either circles or X's along that line plot showing where those values fall. You're doing the movie data for that. B2, describe the variability in the numbers of movies watched by students in your sample. So how did the numbers compare? How did they vary? Were there a lot of low movie watchers? Were there a lot of high? What happened there? 3, compare your distributions with those of other members in your class. Describe any similarities or differences. So why don't you just join a different group here quick and look at their data compared to yours. 4, what can you conclude about the movie watching behavior population of 100 students based on the samples? Okay, so use your sample and maybe that other group sample and make a general statement now about what the habits of 8th grade students watching movies is. All right, now we are not going to do C1. Okay, we're not going to do C1. Instead, I'm going to give you a new assignment here to talk about the relationship between the hours of sleep the students got and the number of movies they watched. So I want you to make a scatter plot. And on the x-axis, you're going to have those numbers of movies. Okay, so it's going to be just like your line plot before. On the y-axis, you're going to have the number of hours a student slept. Okay, so with your 30 students, you should have 30 points plotted on this scatter plot. Make it a high quality scatter plot, labels and a title, and go ahead and pause the video and plot those points there. So now we're going to answer some questions about your scatter plot. What do you notice as the number of movies a student watched increased? What happened to the number of hours of sleep that they got? Or you could answer that in the other way, as the number of hours of sleep increased, what happened to the movies? Is there a correlation here? Is there a positive, negative, or no correlation here? Could you answer that question in your notebooks? And then on your scatter plot, I want you to fit a line of best fit to your data. Okay, make sure it goes all the way through the graph, covers 2 nice points, similar to what we did last week before the snow days. And then I want you to write an equation of that line in the form y equals mx plus b. Make sure all this is getting down in your notes. And then I want you to pause the video and talk to your partner about what does the slope mean in the real life situation. So what is the real life situation of your slope in your line? And then what is the real life situation of your y-intercept of your line? And then I'd also like you to make a general statement here about the relationship between hours of sleep and number of movies watched of 8th graders. And when you are done with that, you can check in with me and we'll go over your answers and see if you're ready for 2.4.